77. Today we're going to look at that other piece of the fundamental theorem of calculus that we haven't talked about yet, and that is derivatives of integrals. Well, I want you to just think about this really quick. Let's say we have a function, and then we do the integral of that function. Then we do the derivative of the integral of that function. What's going to come out of that? Well, an integral is like an antiderivative. So if you do an antiderivative, then a derivative, we should end up right where we started. Okay? So this is kind of a weird thing to do, but it's a very common thing and is done a lot on the AP exam. So let me just start with an example. So I'm going to define a function f of x. F of x is going to be the integral from 0 to x of 4t squared minus 2t dt. So here I defined a function f, and I said f of x is equal to the integral from 0 to x of 4t squared minus 2t dt. Now you may say, oh, hold on, what? We got x's, we got t's. Don't worry too much about that right now. So let me ask you a question first. What if I asked you to find f of 2? Well, f of 2 then, right, we would just plug in, everywhere we see an x, we'd plug in a 2. So f of 2 would simply be the integral from 0 to 2 of 4t squared minus 2t dt. And then I could go ahead and do a definite integral. We know how to solve those, right? And we could figure out what f of 2 is. The reason they have t's in there as well as x's is to show that it's like a separate function in there, okay? So you know when you do f of 2, you're not plugging in 2 for where you see the t's, you're plugging it in where you see the x's. Okay, so my question is, right, we could solve that. I'm not going to do that in this video. I'm going to keep it short and sweet. You can do that tomorrow in class. My question is, what would be f prime of x? Well, what I would be doing here is I'd be doing the derivative of an integral of 4t squared minus 2t. But now my function is going to be in terms of x. The derivative and the antiderivative, in a sense, cancel each other out. And what I'm left with is that same function. But now my function is going to be in terms of x. I think of this as kind of just like plugging in x's everywhere you see t's. F prime of x here would equal 4x squared minus 2x. I never had to do, the power rule or anything like that. That's simply the answer. Let's try another one. I'm going to say this. G of x is defined as the integral from 3 to x of sine squared t dt. What would g prime of x be? So this works. We're just going to sub in an x everywhere we see a t and drop all the integral signs and the dt. This works as long as the x is on top of the big S, right? On top of the integral sign. G prime of x then, I don't have to do the derivative of sine squared, right? Doing the derivative of the integral, those two functions undo each other, and the answer here would be sine squared x. Done. Let me give you another example. H of x is defined as the integral from x to 9, that's a 9, not an a, x to 9 of the natural log of 3t squared dt. Now I want you to find eventually h prime of x. Now we have a little bit of a problem here. This works when the x is on top of the integral sign. The x is on the bottom. Oh no, what do we do? Mr. Hartz, I don't know how to do this. No, don't worry. You know exactly what to do. How could you rewrite this integral so x is on top? Well, all you'd have to do is flip-flop the 9 and the x, but remember, what adjustment do you have to make for doing that? Well, you have to throw an opposite sign out in front of the integral. So I'm just going to rewrite h of x to be this. Well, that's just the opposite of 9 to x. ln 3t squared dt. Now when I do h prime of x, I just keep that negative sign, and I got ln of 3x squared. Done. In a sense, all I did was flip the limits of integration and threw an opposite sign out in front. Then I can plug in x. Where things get a little bit dicey is when we have things other than just regular old x up there. Let me show you this example. And we are quickly running out of time. So this is going to be a quick example, and we'll run with it tomorrow. Okay, now again we're going to find f prime of x. Well, this is going to work like the chain rule works for derivatives. Okay? So the derivative of an integral is that function, right? Right? The derivative of an integral of a function gives that function. But this integral is going from 2 to x squared. So all I'm going to do is plug in my x squared everywhere I see a t, and then I have to multiply my answer by the derivative of x squared. Okay? So let me show you what this looks like. By the way, your answers should never have the integral sign in them, right? There's simply the function comes out. So here's what this is going to look like. There's a couple tricky places here. This is going to be 4, and I'm replacing t with x squared, but that t was still being cubed. Okay, that's my original answer. Then I have to multiply that answer by the derivative of x squared, by the derivative of whatever this function was. So I got to multiply by 2x. Simplifying this down, x squared cubed is x to the 6th. And simplifying it down one more time, we get 8x to the 7th plus 10x. And that would be f prime of x. Okay? So if we have something other than regular old x up there, just plug it in as you see it. But then make sure you multiply by the derivative of that function, of that thing that you're plugging in. Okay, in this case it was 2x, right? That's it for today. You're going to see the power of this is going to be evidenced to you tomorrow in class. Okay, and we'll keep working on some of the other stuff that we've been working on too. That's it for today. See you guys later. 2 chains, bye.